This is u5L3, and we are going to learn how to factor and solve polynomials. So here is a flow chart that's going to guide you through the process of factoring. Okay, polynomials, there are many different ways of factoring depending on what kind you get. So make sure you copy the notes down and use this flow chart. Use it all the time when you're doing these problems. Okay. So the first step always in factoring is to factor out the GCF. So for example, I have 6x to the fourth plus 9x squared. Remember GCF, do that to the numbers, okay? What number can you get out of 6 and 9? Meaning which number can go into both 6 and 9? That would be 3. And what can go into x to the fourth and x squared? That would be x squared. So you take out 3x squared, and what's left is 2x squared plus 3. Okay, it's basically the opposite of distributive property, right? And then after you do that, you try to factor the rest, what's left inside, okay? So after you do the GCF, you're going to try to factor. And when you do that, you have to look to see if whatever you're trying to factor, is it 2 terms or 3 terms or 4 terms? These are the ones that we know how to factor. We're going to learn how to factor them, okay? Anything beyond this is it's much beyond the scope of this class, so we're not doing that. It's just 2 terms, 3 terms, and 4 terms. Okay, so 2 terms look like this, right? X squared plus 9. So x squared is a term, positive 9 is a term, or you have like 4x cubed minus 3. 4x cubed is one term, and minus 3 is another term. And 3 terms look like that, and 4 terms look like that. Okay, so make sure you guys know the difference. When you look at that, you should know exactly, oh, is it 2 terms, 3 terms, or 4 terms? If it's 2 terms, you have 2 different cases, right? If they're squares and if they're cubes. And what I mean by that is, when it's cubes, both your terms have to be cubes. Look, the 8 has to be a cube because 2 cubed is 8, right? And then x cubed is a cube, obviously, and negative 27 is also a cube because negative 3 cube is negative 27. So both of them are cubes, 2 terms. Each term is a cube. In squares, same thing. You have 2 terms, and both of them are squares. X squared is a square, and 9 is a square, right? Okay, let's talk about the squares first. In squares, you have 2 different types, right? One would be the difference, and one would be the sum. And what does that mean? Sum means the 2 terms are adding to each other. Okay, 2 terms are both positive. The difference means one term minus the other. So one's negative, one is positive. Okay, so in the difference, there's a formula, and we've learned this already, right? This is basically a quadratic with no term in the middle. So we learned this. If you have a squared minus b squared, it's equal to a plus b and a minus b. Here, I have a squared minus b squared because both of them are squares. So what you want to do is you want to figure out what is a and what is b in this case. Like a is a square root of x squared. So a is just x, right? And b is a square root of 9, which is 3. So a is x and b is 3. You see how x squared is a squared, 3 squared is b squared, which is 9, right? So following that formula, I have a plus b, which is x plus 3 times x minus 3, right? So every time you see 2 squares minus each other, that's the pattern that you use, okay? Now, when you have squares that are added to each other, you can't do it. It's not factorable. You're done there. You stop. Now, in terms of cubes, there are also 2 different scenarios. One is difference, again, and one is sum, of course, right? So difference would be something like this example is difference, right? Because it's one term minus the other. Difference means subtraction. Sum means adding. So I have one subtract the other. The formula is this. Oh, whoops. The sum means that adding to each other. There it is. And the formula for the difference is that a cubed minus b cubed. Remember, we're talking about cubes now, not squares, right? Cubes is equal to a minus b times a squared plus a times b plus b squared. Okay, so in this case, again, you have to figure out what is a, what is b. A is the cube root of the first term. So that would be 2x. Right? A is 2x, and b is 3. And these are the cube roots of these guys. And then you follow the formula, you get a minus b, right? So 2x minus 3. And then a squared is 4x squared. And then a times b is 2x times 3, which is 6x. And then b squared, which is 3 squared, which is 9. All right. Same thing down here, but the formula is slightly different here. If you have a cubed plus b cubed, you have a plus b. That's the difference there. And then a squared minus ab plus b squared. Again, you figure out what is a and what is b. So a is the cube root of this, which is 3x, right? A is 3x. And b is 1, because 1 is the cube root of 1. Okay? 1 is the square root of 1, the cube root of 1, the fourth root of 1. Right? And then you follow this formula, a plus b, so 3x plus 1. And then 9x squared minus 3x times 1 is 3x, plus 1 squared is 1. Okay, so now we're done with the two terms, right? All the two terms are done. Now we do three terms. So 3 terms, you do it like this. You factor them like a quadratic. So here it is. It looks just like a quadratic, and it works just like a quadratic, right? So what you do, you want to split the middle term, right? Remember that? Right? 1 times negative 10 is negative 10, and split that into two numbers that add to be 3. So I split that into 5x squared minus 2x squared, right? Because the middle term is x squared, so it's got to be x squared in both of these that you split out. Right? And I chose 5 and negative 2 because they multiply to be negative 10. Right? And then you group them, and you factor out the GCF from each group. So I factor out the x squared from the first and the negative 2 from the second group. Now I have x squared plus 5. See, x squared plus 5 is the same. Now I just put them together. X squared minus 2, x squared plus 5. Then I'm done. Well, I actually have to look at this here. Can I factor this? These are two terms, right? Are they perfect squares? Well, this is x squared, but 2 is not a square, right? 4 is a square, 9 is a square, 2 is not a square. So 5 is also not a square, so I can't factor anymore. But you should check them even when you get down to here, because sometimes you factor like different types in the same problem. Now the 4 terms might be the easiest. 4 terms you just factor by grouping. So you group the first 2, and they group the second 2, or the first 2, and then the third and the fourth into 2 groups, and then you just GCF both of them. Right, so I take out x squared from the first 2, and I take out 3 from the second group, and have x minus 4. If these are the same, you can group them. So x squared plus 3, x minus 4. Again, this is an x squared plus 3, 2 terms, right? But 3 is not a square or a cube, so we're done. So here are some examples. You factor this completely. Again, this is, now you have to look back at the chart, right? What is the first step? GCF, right? Is there any GCF in these? Yeah, GCF is the x, right? So I take out the x. Now I have this guy left. Now I look at this guy here. Is it 2 terms, 3 terms, or 4 terms? It's 3 terms, right? 3 terms. So you factor like a quadratic. So I split the middle term into 5x minus 3x, and I group. Okay, I group the first 2, group the last 2, and then take out the GCF from each group. Remember my x in the beginning, the x I took out as a GCF, it stays with me the whole time. You see that yellow one stays there the whole time. And I deal with the inside, right? So here I factor like a quadratic, and then I have just x times x minus 3, x minus 5. That yellow x is still there. It's a factor. You have 3 factors, okay? How about this one here? First step, GCF. I take out 2y cubed. So I have y squared minus 9. So this is your GCF. It stays there. What's left? Is it 2 terms, 3 terms, or 4 terms? It's 2 terms, and they are squares, not cubes, and they're a difference. So you follow the flow chart, and what does it say when it's two terms and it's squares and it's difference? All right. So you have the pattern, so you have to find out what's A, what's B. A would be Y, B would be 3. So now you follow that formula and you get Y minus 3, Y plus 3, and the GCF is still there. Here's this one. First step, GCF. Is there anything to take out? Well, there's no X in the last term, so the variables can't be taken out. And the numbers seem like nothing you can take out either. So there's no GCF to take out. You go on to the next step. Is it 2 terms, 3 terms, or 4 terms? This is 4 terms, so you just factor by grouping. So you group the first 2, group the last 2, take out the GCF. So here I can take out x squared, and here I take out the negative 16. So there it is. I have this. X minus 3 is the same, so I can just group this now. So x squared minus 16. Now I have to look again. X squared minus 16 is 2 terms, right? And each of them is a square, and they're different. So I can factor this again. So I find out A and B. A is X, B is 4. So I factor that, and I get X plus 4, X minus 4. And then X minus 3, can't factor that, right? Because it's already lowest degree for X. Okay, next problem. I have 27x cubed minus 64. First step, GCF. Is there anything to take out from 27 and 64? No. 27, the root of 27, the factor of 27 is just 3 and 9. Can't do that with 64, so no GCF. And then I look, 2 terms, 3 terms, or 4 terms. It's 2 terms, right? 2 terms, and they are cubes, not squares, and they are difference. So follow the formula. A is 3x. Okay, remember the cube root of 27 is 3. The cube root of x cubed is x. Cube root of 64 is 4. Follow the formula. Difference is a minus b, so 3x minus 4. And then a squared is 9, right? 3 squared is 9. X squared is x squared. And then a times b is 12x. And then b squared is 16. This one here, again, GCF is 5. So I have x squared. Oh, that should be 25, not 5. And then that should be x squared plus 25, okay? So 2 terms, squares, sums, you're done. Because they're added, you can't do anything to it. Okay, you stop here. But that should be a 25. So even though they're both squares, they're added, so you can't do anything. It's not factorable. You're done there. Now this one here, no GCF, right? Because there's no number here and there's no x here. So no GCF. And so 2 terms, they're cubes, and they're sums. So follow the formula. A is x, b is 4. The formula tells you x plus 4, x squared minus 4x plus 16. This one, there's no GCF. Okay, this one doesn't have a number. This one doesn't have an x, so no GCF. Then it's 3 terms. So you factor like quadratics. Split the middle term. So 7 and negative 2 gives you 5, and they multiply to be negative 14. So these are the numbers we choose. And then you group the first 2, group the last 2. Take out x cubed from both of them. And then take out a negative 2 from the back. Now I have x cubed plus 7. See, that's the same now. So you can put them together. X cubed minus 2 times x cubed plus 7. Now you look at these two here. X cubed minus 2, can I factor that? That's 2 terms. Are they squares? No. Are they cubes? No. Then you're done. This guy here, also the same thing. 2 terms, but no, not squares, not cubes. So you're done. This one, GCF would be 5. So 5 times x cubed plus 8. And the remaining is 2 terms, and they're cubes, and they're sums. So x is a is x, b is 2. Follow formula for 2 terms, cubes, and sum. Yeah, the 5 is still there, and then x plus 2 times x squared minus 2x plus 4. Now, when it gets to solving, it's exactly the same thing, okay? Solving, imagine this is your equation. You can solve now because it's an equation. The other ones you couldn't solve because there's no equation, they're just expressions. If you have an equal sign, you can solve, okay? So first step, move everything to one side. So I subtract 50x from both sides. Remember, you cannot divide the x by both sides, okay? You can never divide by a variable because it might be 0. And then you divide by 0, it doesn't work. So you can't divide, move everything to one side. So I have 18x cubed minus 50x equal to 0. Then the second step is to factor. So to factor, the first step in factoring is GCF. So I take out the 2x. I have 9x squared minus 25. And I can still factor some more, right? These guys here is two terms. They're squares, and they're different. So I factor that. A is 3x, B is 5. Okay, so factor that, I have 2x times 3x minus 5 times 3x plus 5 equal to 0. And then the next step is to set each factor equal to 0 and solve. Remember, the 2x is also a factor, right? Because we factored that out GCF in the beginning. So 2x equal to 0, and then 3x minus 5 equal to 0, and 3x plus 5 is equal to 0. And you solve for each of them. Divided by 2, x equal to 0. Add 5 to both sides, divided by 3. Subtract 5 by both sides, divided by 3. Okay. Last problem, I think. Here it is. First step, move everything to one side. I got to add 21x to both sides. Oh, that should say 21x and not 36. Whatever. So I have everything on one side now, but not 36. Put 21 there, right? And then you factor that. I take out an x. So I have x to the fourth minus 10x squared plus 21. And then the remaining, there are 3 terms. So you factor like quadratic, split the middle term. So I split it to -7 and -3 because that gives you 21. And then you group them and you factor out just like what you do with quadratics, right? And I have this. And then set each of them to equal to 0. So x equal to 0, x squared plus 3 minus 3 is equal to 0, and x squared minus 7 equal to 0. And solve. This one is already solved. So this one, you add 3 to both sides, square root both sides. Add 7 to both sides, square root both sides. Then you're done.